Okay, everybody. So the last topic that we covered, it was about the CVD material balance. Oh, sorry, the DLE and separated test material balance. QC. Uh, in the and what we discussed there is that like for example, when we are doing the DLE material balance and we are doing, for example, the density material balance calculation. So generally labs they provide the reported densities are actually calculated from the material balance. So when we do the material balance, occasionally the calculated densities are uh, perfectly aligned with the reported densities, and that doesn't mean that um, the reported densities are of good quality, and that only suggests that the reported densities are calculated from the material balance, and the accuracy of the densities, the reported densities, depend on how accurate you have measured, for example, the oil shrinkage BO, and for example, the gas gravities, and the removed gas volumes in the DLE or the RSD and the solution gas oil ratio. So the problem is that the, like it's hard to say, like if you look at the DLE data, it will be hard for you to say, okay, whether there is any issue in the DLE data. So so there is another method that we can actually check for consistency between the lab reported data across different experiments. So the QC, or the type of QC that we are going to talk about now, is not relevant to a specific PVT experiment. Okay, so we will not be doing a QC for one particular experiment. We will be comparing the data from the different experiments, and we will see if all those numbers, like from the different experiments, if you have a CCE and a DLE both, or if you have a CCE and a CVD experiment, or if you have all three experiments, CCE, CVD, and DLE, then the reported data has to be consistent across the three different experiments, and we will see how we can check that. And if there is like in that QC, if you find that the data is not consistent across the different experiments, that kind of show you that there is some laboratory measurement error, uncertainty in measuring, for example, in getting or measuring the data for either of those experiments. Okay, so and also, before we jump to this new topic, or like the new type of QC that we are going to discuss, um, I just wanted to um, mention that when we were going through this the material balance QC of the CVD experiment, there I when we were discussing the importance of the CVD material balance, like what is the consequence if you have a bad material balance versus if you have a good material balance. So there I mentioned that if you have a good backward material balance and a bad forward material balance, then there are some published papers that you can use to go about doing some corrections in the lab reported CVD data. So and I promise that I will be uploading the papers associated with with those methodologies. So I can just quickly show you that those papers will be provided with the course material, and so those are here in the references, and then these are the two papers, 17685 and SP 17768, which talk about uh, like how you can go about doing some corrections in the CVD data if there is inconsistency, and if the material balance, like especially if our material balance is wrong. Okay, so yeah, so with this we can talk about this new QC where we will be comparing the data from the different experiments and check for consistencies. And before we talk about the method itself, we need to be we need to know like what are is what are the different types of relative oil volumes reported, for example, in a CCE experiment, because this QC is comparing the relative oil volume from the CCE experiment versus if you have a CVD or if you have a DLE or if you have both experiments, then we will be comparing the relative oil volume data. So, but again, before we go into the main topic, this uh, yeah, this it's important to mention that in a CCE experiment, you can find two types of relative oil volumes. One type of relative oil volume is defined as the oil volume at any given pressure divided by the volume at the saturation pressure, which is this remains remain constant because the saturation pressure is constant. Okay, so this remains constant at all pressure. So the only thing that's varying with respect to pressure in this VRO type 1, is the oil volume. Okay, and then we have this second type, which is VRO versus VRO as a function of pressure, is the function of is equal to the oil volume at a given pressure divided by the total volume, meaning that oil plus gas volume at the given pressure. Okay, so if we just quickly look at the report that we have, like we have two reports, gas report and the oil report. So if you go to the CCE experiment and look at this two oil volumes, so we have this two relative oil volumes reported. So V liquid over V total and V liquid over V saturated volume. Okay, and similarly, if you go to the oil PVT report, okay, so here we again have V liquid over V total and V liquid or like V oil over V saturated volume. Um, so in this PVT report, we have both relative oil volumes, but most labs the PVT labs they can provide you either with just one relative oil volume data, or they can provide you both numbers. And in either case, you need to know what data they have provided you, because for this QC, the relative oil volume that we will be using is this one. Okay, and we will see the reason why that's the case. But if you have a CCE data, if you have two relative oil volume columns, then you should know which one the lab is reporting. And generally, labs they provide footnotes in the PVT reports. When they provide the data in the table form, they provide footnotes to give you the definition which one is what. And if they have provided you only one type of relative oil volume, then again you have to be careful, like what type of data they have provided, what type of relative oil volume data they have provided. And again, that might be there in somewhere in the footnotes of the CCE data, or maybe in the column header. Okay, so if we have both types of data, and in these figures, there is just shown that the comparison of how the two types of relative oil volumes may look like. So this is the case of, for example, a bubble point system. Okay, so if you have a bubble point system like an oil system, so in that case, this second one, the relative oil volume, second one remains at 1. The fraction remains at 1, and then it decreases sharply because the gas volume is the gas compressibility is higher and the gas volume is dominating. And the first one, and the relative oil volume is not equal to 1, so it is changing, and this is kind of giving you the compressibility of the oil. Okay, and then that's how this relative oil volume, this first one, changes with pressure below the bubble point. And similarly, on this right hand figure, again we have the same comparison, but now for gas condensate system. Okay, and again here we can see how the two types of relative oil volume look like for the gas condensate. Okay, now the question is, like, for example, if the lab has reported only one type of relative of oil volume and then you want to calculate the other one, and the reason why you need the other one is because we as we said, we will be using this first type of relative oil volume for doing this kind of QC that we are going to talk about. So if you have, let's say, if you have only this relative oil volume, the second type, which is here, so that's this relative oil volume of the second type, and then you can calculate this relative oil volume of this first type by just this multiplying this second type of relative oil volume with VT over VS. And what this number is, this is always reported in the CC experiment. So this what you call this VRT, the total relative volume. Okay, and where is this total relative volume in our PVT reports? So that's this number, relative volume. You see V over V, VT, this is V means V total or saturated volume, and then we also have the same in the gas relative volume or relative total volume. Okay, so yeah, so we need that, and we just multiply this with this second type of relative oil volume to get this first type of relative oil volume. Okay, so again, important, uh, PVT labs, they can provide either one or both, and then you have to check, like, for example, footnotes where they can provide you the definition of the different types of relative oil volumes they have provided. And it's also important, and the reason, again, the reason why we will be using this first type of relative oil volume for QC is because when you look at the CVD experiment, okay, we know in the CVD experiment the total cell volume is always equal to the volume at saturation pressure. Okay, so in CVD, V total is always equal to Vs at all pressure, right? um, So that's why in the VRO, the relative oil volume reported in the CVD experiment, that's just the ratio of oil volume divided by the saturated volume. And if we will be doing the QC, like comparing the CCE relative oil volume versus the CVD relative oil volume, then we should have the same type of relative oil volume. And in CVD, since we have only one type, then that's why we have to choose the same type from the CCE experiment where we have the choice of two different types of relative oil volume. Okay, and then in the DLE experiment, so if you have the DLE experiment, their labs, they don't provide you any relative oil volume. There is no relative oil volume in a DLE experiment. But again, uh, with the lab reported data, you can calculate the relative oil volume, and it's very simple because we know that the definition of the relative oil volume here that we are interested in is the oil volume divided by the volume at saturation pressure. And in the LE experiment, we know there is a property called BOD, which is the oil formation volume factor. Okay, so if you want to calculate VO over VS, that will be just the ratio of the oil volume from the DLE test divided by the oil volume from the DLE test at the bubble point, or which would be our saturation pressure, right? Because BO is equal to VO at any given pressure divided by the residual oil volume. So the residual oil volume is the same for this guy and this guy here. That will be cancelled out. So it will be just the ratio of VO at any given pressure divided by, so this will be Vs over VOR. So this will be Vs here. Okay. Vs, or you can say the oil volume at the bubble point, or the saturation pressure. So that's how you can calculate this VRO from the DLE experiment, and then we should be able to compare the VRO from the different experiments. Okay, with this, one important comment regarding the CCE experiment for the oils is that generally, if you have very low GOR oils, like if you have oils with less than 1,000 or 500 scoff per barrel, and even like we have seen uh, for some volatile oils, when PVT labs they do the experiment, like the CCE experiment, even though they would be using a window PVT cell, and they can see the interface of the oil and the gas phase in the PVT cell, they generally don't report the two-phase, they generally don't report these relative oil volumes in the CCE test. So like in this PVT report that we have for the oil, even though the not this one, but this one here. So even though this oil has very low GOR, so you can look at it from this separator test. So the GOR is like 236 scoff per barrel, right? But when you look at the CCE experiment here, we have the liquid, we have the VRO reported for this type of oil, okay? But generally, if you have this kind of fluid and you send the sample to the lab and they do the CC experiment, they will not provide you these numbers. And if you don't have those numbers, then it will not be possible for you to do this type of QC, because having VRO from the CCE experiment is the key for doing this, for doing the QC that we are talking about. Okay, so and into the, like, generally now PVT labs, they almost always use a window PVT cell, and they have the opportunity to measure the individual phase volumes at each pressure. So meaning that they can provide you these relative oil volumes if you ask them to do that. So that's why we always recommend that no matter what kind of oil you have, low GOR, high GOR oil, if you do the CCE experiment, if you are going for a CCE experiment, always ask the lab to provide you this relative oil volume data. Okay. So yeah, that was an important comment. Which I can just mention here. Always ask the lab to use window PVT cell for CCE test and report VRO as a function of pressure data. Okay, so that's important. Okay, now we will see how the QC can be done actually, and the basic idea is that when we will be doing the QC, we cannot do a quality check of the entire relative oil volume data, but at least we can check for the consistency between the relative oil volumes from the different experiment at one pressure. Okay, so and what do I mean by that is that if you have a CCE experiment, okay, if you have a CCE experiment and if you have a CVD experiment, then the relative oil volume at a pressure P star is should always be equal to the relative oil volume from the CVD experiment at the same P star pressure. Okay, and just let's forget about the DLE for now. But if you have CCE and CVD, most probably if it's a gas condensate reservoir, even for volatile oils and critical fluids, we recommend to do the CVD experiment. So if you have a CCE and CVD both experiments, the CCE relative oil volume should be equal to CVD relative oil volume at this special pressure P star. And what does this pressure mean? P star is the first depletion pressure below the saturation pressure in the CVD or DLE experiment. Okay, so we know that the CVD or DLE experiment, it's always starts from the saturation pressure, being a bubble point or a dew point. So the first pressure that you get below the saturation pressure in a CVD or DLE experiment, the relative oil volume at that pressure should always be equal to the relative oil volume at the same pressure in a CCE experiment. Okay, and basic idea is that in CCE, because we are not removing any composition, in CVD the composition starts, we start removing the, or in a CVD or DLE composition, we start removing the composition from the second pressure, right? So when we deplete the total reservoir, total fluid composition to the first pressure below the saturation pressure, the equilibrium phases should be the same that as we have in the CCE experiment, because the composition that we are flashing to the first pressure, first depletion pressure, is the same both in CCE and CVD. Okay, so that's the idea. So if you have a CCE and CVD, these two numbers should be the same. And if you have a DLE experiment, so if you have CCE and DLE only, then this guy has to be the same as this one. Okay, so they both have to be same. And if you have all three experiments, then that's the best thing you can ever have. And there you can actually then the VRO should be the same across all three experiments. Okay, so let's try to do this QC for the PVT reports we have. Okay, so first we go through the gas condensate PVT report, and if we go, for example, gas condensate PVT report, the first thing that we would like to know, what is P star. Okay, so we go to CVD. Okay, so we can see here that the saturation pressure is 6726, and then the first depletion pressure below the saturation pressure is 5500 psi in CVD. So we can go here and note down this is 5500 psia. Okay, now we go to the CCE experiment and see what is the VRO. What is the VRO value at 5500? So this is 5500 here, and then VRO again. We have two numbers, two columns here. Which one to choose? We know we are interested in this one, this guy here. So VRO at 5500 is 37.81%. So this should be 37.81%. And then we go to the CVD experiment and see what is the VRO there. So that is 37.81. Okay. So that's how you can do this QC. Very simple one, but again, it gives you an important information about the consistency of the different PVT experiment. Okay, and the question would be like, if for example, if they are not the same, which one are you gonna blame? Like which one is inaccurate, whether it's a CCE experiment or CVD? So just doing this QC, it's not uh, you cannot tell. Like if you only do this QC, you cannot tell whether it's a CCE experiment that's wrong or a CVD experiment. But like if you uh, but if you have done other QCs, for example, if you have done material balance QC on the CVD experiment, and if you combine that information with this information, then you can tell something about whether you have uncertainties. For example, if you did the material balance QC on the CVD experiment the forward material balance is very poor, then okay, you can, and the backward material balance is very good, then we know the forward material balance is heavily dependent on the relative oil volume data, and most likely that's the relative oil volumes that is not measured accurately, and that may be wrong in the CVD experiment. But again, it can also be wrong in a CCE experiment. But which one is more wrong, you cannot say for sure. But the only way then the only way to be sure which one you should weigh more during an EOS tuning, for example, process is that when you develop the equation of state model with an initial EOS model that is characterized properly with all the C7 plus characterization methodologies that we discussed during the advanced PVT course, the predictions should be reasonable for the relative oil volumes. Okay, so if you have like if the relative oil volumes are reasonable, for example, a CCE experiment, but not for the CVD experiment, then you know, okay, maybe there was some problem while measuring the relative oil volume data from the CVD experiment. Okay, so that's how you can gather all the puzzles and then just try to get the information out of it. And there, of course, the most important factor is the experience working with these kind of problems. And now we go to this oil PVT report, where and this exercise a little bit challenging, but not too much. So again, we go find the P star value. So oil PVT report, this DLE. We go to the DLE data, and it is 1800 below the saturation pressure. Okay, so we go back. The P star is 1800 psia. The relative oil volumes in the CCE at 1800 psi. So we go here and see if we can find 1800 psi, and you can see here we don't have that, and that can be very common finding. Like in a CCE experiment, the pressure steps, you may not find the exact same pressure step below the saturation pressure that you have in a DLE or CVD experiment. But what you can always do, if the pressure steps are close, like here it's only 100 psi, then you know that if you do the interpolation, that would be a reasonable approximation, and you can get a reasonable value. So what we need here is a value at 1800 psi. So we need this V liquid over V saturated at 1800 psi, and we have the value at 1900 and 1700. So if we just take the arithmetic average of the two numbers, that would be a number at 1800 psi, which is kind of doing linear interpolation, right? So we have 99.33 and 98.04. So 99.33 plus 98.04 divided by 2. So that would be 98.67%. Okay. So this is just doing the linear interpolation. Okay. And then in the DLE, what do we have? So again, in DLE, we don't have relative oil volume data, but again, as discussed, we can calculate that value, and that would be the BOD at the given pressure divided by the BODV. So 1.24 divided by 1.247. So that would be 1.240 divided by 1.257. That would be 98.64%. Okay, so that again consistent. Both are almost same. So it means that the VRO data is consistent both in CCE and the oil formation volume factors reported in the DLE. The VRO data from the CCE and the oil formation volume factors in the DLE, they are kind of consistent. Okay, so this was a special topic regarding the QC, comparing the data across the different experiment and try to see if they are consistent in terms of data. Uh, okay, so yeah, with this we finish this topic here, and then we'll come back with a new topic in this course.